We've seen a simple hierarchy throughout this series. The membrane begins as a flat two-dimensional surface. When enough energy concentrates in one place, it extrudes into a third dimension, and that extrusion is what we call matter. The dimensional extrusion hypothesis asks a simple question: why should this process stop there? The hypothesis states that any contiguous surface of n spatial dimensions has the potential to extrude into the next dimension up, provided sufficient energy is present to overcome the threshold, analogous to membrane surface tension at the next level up. The 2D membrane extruding into a third dimension is the mechanism we have already established for the formation of matter. The same principle, applied one level up, would allow a sufficiently energetic three-dimensional structure to extrude into a fourth. Wave physics does not need to postulate new mathematics. The Nash-Kuiper theorem in mathematics establishes that low-regularity embeddings of surfaces into higher dimensions are geometrically possible. The most provocative application of this idea is to consciousness. This is speculative, and the book presents it as such. But the argument runs as follows. Every neuron, being a molecular structure, is a knot complex. A brain is an enormously dense, highly active network of knot complexes, all coupled through the shared membrane. A sufficiently dense and active knot network, the argument goes, may cross a threshold analogous to the yield threshold for matter formation. Instead of a single knot extruding from the membrane plane, the entire connected network extrudes into a higher dimensional branch. That branch, in this picture, is what we experience as conscious awareness. It is a topological structure, anchored to the physical brain and governed by the same mechanical laws. Identity and possibly memory on this model are not stored as abstract information states, but as persistent topological configurations of that branch, tethered to the knot geometry of the brain's atoms. This picture has some interesting mechanical consequences. Because the branch is tethered to the physical brain, if the brain is damaged or fatigued, the tension available to maintain the branch fluctuates, and the quality of the conscious experience changes accordingly. The branch cannot exist without its physical anchor. The inertia of established thought patterns, the difficulty of shifting focus rapidly from one complex task to another, reflects the mechanical work required to reconfigure the branch's orientation relative to its anchor. These are not metaphors. They are predictions about the behavior of a physical structure. The threshold at which a developing brain first crosses into this configuration, the moment when a sufficiently complex knot network first extrudes into what could be called the mental dimension, is not yet derived. Identifying that threshold and mapping the connections between the physical and mental branches is a direction for future research. The hierarchy does not necessarily stop at two levels. If the mental branch itself can accumulate sufficient energy and density, either from a single individual or a sufficiently dense network of interacting minds, it may extrude into yet another dimension. What that would correspond to experientially, if anything, is entirely open. Wave physics does not claim to answer that question. It claims only that the same principle that produces matter from the membrane may produce further levels of structure from matter, and that the hierarchy is in principle unbounded. In the next video, we will discuss the Heisenberg uncertainty principle, which may not be as fundamental as it is often assumed to be.